Hi, in today's lesson 11.7, we're going to talk about surface area and volumes of cones. The first concept we're going to talk about is the volume of a cone. Now, what you guys see here is a cone with a bottom base, of course, a circular base with a radius of r and a slant height of L. We need to denote that the slant height is not the height of the cone. The slant height is the distance from the top vertice to the center, not to the center, but to the edge of the circle. And h right here, this is the actual height of the cone. So what we're going to try to do is we're going to try to find the volume of the cone. Now we're going to take a look at this in terms of what we knew about pyramids. Now in pyramids, we talked about the volume of a pyramid to be the area of the base multiplied by the height of the pyramid, all divided by 3. So this is pretty much the same idea. The only difference is that the area of the base is a circle. So we're going to substitute that with a pi r square. The height of that pyramid would be the same as the height of the cone, which would be h, all divided by 3. So with that, we have derived the volume of a cone to be pi r squared times h over 3. And we're going to be using this in further applications. For the next piece, we're going to turn to page 345. Now, in this page, we're going to talk about the surface area of a cone. Now, the surface area is the sum of the base plus the lateral area. So if I were to draw a cone like this, I have a radius of r and a slant height I'm going to call L. Now, if I were to cut this up, I'm going to get the equivalent to the circle that's at the bottom plus part of a bigger circle, not the full circle though. Now, how can we see that? This bottom part right here is this circle right there. So we already know that has a radius of r, and we know that the area of that circle is pi r squared. Now what we need to do is we need to find out what the area of part of this circle is going to be. Now the radius from here to here is not going to be r. The distance from here to here is the same distance as this point to this point. That means that this has a radius of L. So what we're going to do is we need to find out what that area is going to be. So in order to do that, we're going to look at the circumferences of this right here compared to the circumference of the whole circle. Now, how are we going to get that? Now, if we think about this distance right here, okay, let me get a highlighter so I can show you. Okay, the distance around this circle happens to be the same distance as this. So what exactly is that distance? Well, if we look at the distance around here, we know that the circumference of a circle here, it's 2 pi r. Now, the circumference of the entire circle, if I were to actually enclose the whole circle, would be 2 pi L. So that means that this distance right here divided by the whole distance would give me the percentage of this piece right here. So 2 pi r over 2 pi L gives me the piece of the circumference right here, kind of like the percentage of. Now, if we think about this, the area of this entire circle is pi r, whoop, not r, pi L square. Now, if I multiply these two, I would get the area of this circle right there, or part of that circle. So simplifying this, the area of this region, okay, the two pi's divide out, and you're left with r over L multiplied by pi L squared. The L right here divides out, giving me the area of that figure, of that piece right there, as pi r L. All I'm doing is I'm moving this to the front, move this right here, and I left the L the same. So that means that the area of this figure is pi r L. So finally, we can now have an equation for the surface area of a cone, and that is pi r squared plus pi r L. And this is the equation for the surface area of a cone. And this is what we're going to be using right now in the next examples. Let's take a look at the first example. Now, before that, let me tell you where the problems are going to go. Turn to page 346. And you will be doing problem number 1 right at the top. At the bottom, you're going to do problems 2 and 3. Turn to the next page, and you'll be doing problem 4 right there. Let's revisit the equations again. The volume of a cone is pi r squared times the height divided by 3. In the previous page, the surface area of a cone is pi r squared plus pi r L. So let's go ahead and start the problems. Here's number 1. In problem number 1, they want me to find the surface area of the right cone. So remember, the surface area is pi r squared plus pi r L. Remember that L is the slant height. So we need to identify what is the radius. The radius is 4, and the slant height happens to be 6. All we need to do is substitute. That's going to give me pi multiplied by 4 squared plus pi times 4 times L, which is 6. 4 squared, that's 16 pi. 4 times 6, that's 24 pi. So 16 plus 24 is going to give me a total of 40 pi. Now that would be the exact answer. If I want an approximate answer, then I would have to put it in the calculator. So 40 times pi, 40 times pi is approximately 125.7. Make sure you check to see how they want you to round. So this was problem number 1. Pause the video if you need some more time. Let's take a look at number 2. For number 2, it says find the volume of a cone. So the volume of a cone, we already said it was going to be pi r squared multiplied by the height, all divided by 3. All we need to do in this case is put the values in. Whether your height is a height from here to here, meaning like a right like a distance that is vertical to the base, or it's in a slant. Either one will work. So you have pi, the radius is 2.2, and the height is 4.5, all divided by 3. Let's simplify everything in terms of pi, and then we'll multiply everything by a decimal. So 2.2 square, that gives me 4.84 times 4.5 divided by 3. So I'm just going to multiply that and divide it by 3, and I get the volume to be about 7.26 pi. So when I multiply that by pi, I get approximately 22.8. And that would be 22.8 centimeters cubed. I forgot to put the units on the previous problem, but it should be inches square. So check my units. So 22.8. And that's example number 2. Example number 3. We're going to do similarity in using the cones in this case. So the very first thing we're looking for is we're looking for the volume of this cone. Now, we need to find first the scale factor. The scale factor is 9 to 3. So that's 9 to 3, which reduces to give me 3. So my scale factor is 3. What I need to find now is what that's going to be. So that's going to be 3 to the third power, which is equal to 27. Now I need this to be in a fractional form. So I'm going to put a 1 under it. So 27 over 1 is equal to the scale factor of the volumes. So the volume, this is the unknown volume. We're going to call that V. And the volume that we do know happens to be 15 pi. So in order to figure out what the volume is, you have to multiply the 27 by the 15 pi. So 27 times 15 is 405 pi. So once you multiply that and round to the nearest hundredth or tenth, doesn't really say how they want you to round it. I'm going to round to the nearest tenth just for fun. And this would be cubic feet. So that's example number 3. Example number 4. Find the volume of the composite solid. So what we need to do in order to find the total volume, we need to add the volume of the cylinder and the volume of the cone. So for the volume of the cylinder, we're going to be using area of the base times the height. For the volume of a cone, it's pi r squared times the height, all divided by 3. Now keep in mind, this height and this height, they're not the same. This height happens to be 5. This height happens to be 4. So we should not be putting the same value for both of the h's. If it confuses you, call it h1 and h2. We'll call this one right here h1 and the height, this one, h2. So all you got to do is plug it in. The radius of the bottom base is 6. So that's 6 square, and the height happens to be 5. The radius is the same as this radius, so that would be 6 square times the height of the cone, which happens to be 4, all divided by 3. So we need to simplify. 6 square is 36, and 36 times 5 happens to be 180. We'll leave everything in terms of pi for now. 6 squared, that's 36. 36 multiplied by 4 gives me 144, then divided by 3. That gives me 48 pi. My pi's look ugly today. It's okay. They're still good. Get it? Good pies. Anyways, so 48 plus 180. The volume would be 228 pi. Now, if you put that in terms of a decimal, that gives me about 716.3 meters cubed. So this is the last example for lesson 11.7. Please make sure you work on the extra practice portion of the journal and the online homework. Have a good day.